9G, good day. This is a video tutorial on the topic molar mass. So to start with, this lesson was presented to you last week. So it's about the topic on mole. Now, mole concept is very important because this is a basic lesson or topic when you want to study stoichiometry. Stoichiometry is the study of the quantitative aspects of chemical reactions. So it's just like studying the amount of a substance in order to react it with another substance. And of course, this is beneficial also in identifying, or shall I say, identifying the possible products in the reaction. Another, it is very important to know the quantitative aspects of a chemical substance, okay, so that you will know how reactive it will be, or shall I say, in addition, other properties also that will speak about the substance. Okay, so I hope also that this will address our essential question, which is how can the variety of compounds be analyzed and formed, and used. Okay, so to start with, let me remind you that we have counting units, and you are familiar with these counting units. When we say pairs, okay, it means that there are two, okay, sets or two parts. When we say ream, it's a counting unit. So how many papers or pieces of papers are there in one ream? And that's another counting unit. So when we say fortnight, it's 14 days. And when we say dozen, so it's 12. Now, what about in atoms? How do you count the number of atoms? So shall I say, how do we quantify these small particles, such that of an atom? Since atom is a very minute particle. So we are using mole. A mole, or the mole, is a counting unit. It's just like saying a dozen. So instead of 12, okay, when we say mole, it means 600 billion trillion, or in scientific notation, it's 6.02 times 10 to the 23rd, okay, 23rd particle. So that's how we express it in scientific notation, okay? 6.02 times 10 to the 23rd atom. This is what we call as Avogadro's number. Please memorize this number, this value. You will be using this in converting moles to another unit or to a particle. Okay, so an atomic mass unit, okay, is defined as precisely 1/12 the mass of an atom of carbon-12. Well, that's how we measure also the mass of an atom. We express it in AMU, but it's really difficult to figure out AMU. So we will be using the mass in grams. We will be using grams rather instead of AMU. So please take note that where did we get this? This was studied by Amadeo Avogadro, the value of 6.02 times 10 to the 23rd. It was not just fixed, it was measured, okay, using the Millikan oil drop experiment. So if you are conscious of this, if you are interested rather of this, curious in you may try to take a look at how did Amadeo Avogadro work on this using the Millikan drop experiment, oil drop experiment. Okay, but nowadays, X-ray technology is being used. Okay, now for let's focus first for the molar mass. When we say molar mass, the mass of 1 mole in grams. It is equal to the numerical value of the average atomic mass. And where do we get this? We use the periodic table. So when we say 1 mole of carbon atom, it also means 12.0 grams per mole. When we say 1 mole of magnesium atom, it also means uh, 24.3 grams per mole. Okay, so where did I get this? Again, periodic table. For uniformity purposes, we will be using um, 2 decimal places. Okay, now, what are other names? In some books, they are using other names instead of using molar mass. This is very related to molecular mass or molecular weight. Specifically, molecular mass and molecular weight are for molecule, compound, molecular compound, or covalent compound. For molar mass and formula mass rather, for formula mass and formula weight, same goes for compounds, but to be specific, that is for ionic compound. Okay. The goal of this lesson is to convert. It's just like convert meters to centimeters, kilometers to meters. Okay? So we have to learn the process of conversion. And we will be doing that using the factor label method. Factor label method. This method is cancellation of unwanted units. Before we move into this factor label method, we have grams. You need to convert grams to moles, and you need to convert that to particles or particles to atoms. These are the things that you are going to use. Okay? Please take note. I want you to take a screenshot of this or pause this video for you to be clarified. Now, in order to do this, let's learn the basics first. It is very important that you should know how to get the molar mass of a compound. It's easy. If we will be asking, if you will be asked for the atomic mass, just simply get it in the periodic table. What's the atomic mass of carbon? Carbon, go to the periodic table, look at the atomic mass, 12.01. That's carbon. Okay? That's carbon. Now, 12.01. Hydrogen, 1.01 grams. That is the atomic mass of an element. Now, let's take a look at how to work on the atomic mass of the compound. Okay? How to work on the atomic mass of a compound. So let's just say we have a mass in grams of molar mass of molecules and compounds. This is mass in grams of 1 mole equal numerically to the sum of the atomic mass or atomic masses. So let's try to work on this. What if we have the substance calcium chloride? Okay, calcium chloride. Now, how do we calculate for the molar mass of calcium chloride? So to start with, you need your periodic table. Okay, you need the periodic table of elements because you will be getting there the atomic mass. So if we have calcium chloride, let's say I hope what I have here is also clear. Okay, if we have the calcium chloride, we have to count also the number of atoms. The number of atoms is represented by 1 mole. So how many moles of carbon atoms are there, are present in the calcium chloride? So we have 1 mole of calcium. What else? We have 2 moles of chlorine. The shortcut or abbreviated symbol of mole is MOL. Okay? Now, atomic mass. Again, I hope you know where to locate the atomic mass. Now, let's try to locate or give me the atomic mass of calcium. Okay? Atomic mass of calcium. So for calcium, we multiply it to its atomic mass. We've learned that 1 mole of calcium is the grams, it's in grams, right? So the grams is in, let me see first, let me check if I have it here. Okay, so we have 40.01. Okay, 40.1. I hope you get to see that on your 40.1 grams or 40.10. One moment. I cannot find carbon here. I mean calcium. So 40.07. Okay, 78. So if we have that, we have 40.08 grams per mole. Next, for chlorine, we have in chlorine Cl. Please take a look at chlorine in your periodic table. So we have times 35.45 grams per mole. Okay, so what will you do with this one? We multiply that to the value. Then don't forget to cancel out. Okay, so if we have 40.08 grams, therefore, shall I write it here? 40.08 grams. Then 2 moles of 35, 2 times 35.45, we have 70.9 grams. To get the polar mass, all you need to do is to add or get the summation. 40.08 plus 70.9. That is 110.98 grams. Okay? What do we mean by this? 1 mole of CaCl2 or calcium chloride is equal to 110.98 grams. Okay? This is how you get the molar mass. One more. I'll give you one more example or 2 more examples. Okay? So let's have this one. Here we have potassium oxide. Okay? So let's get the molar mass. So we have here 2 moles of potassium. Okay? Times get the molar mass of potassium, and that is 39.098. So we will have 39.10 grams over mole. Okay? Then we multiply it 2 times 39.10. So that is 78.2 grams. Now, for oxygen, there's only 1 mole of oxygen times 16.00 grams per mole. Okay, then we have 16.00 grams. How did we get grams? We cancel out the mole. Then, please get the total of this, 78.2 plus 16 is equal to 94.2 grams. Again, what do we mean by this? 1 mole of potassium slide is equal to 94.2 grams. Okay? I hope that's clear. Now, uh, let's do another example, and that is antacid. Your Kreml is known as aluminum hydroxide. 1 mole of aluminum hydroxide is how much of it is present. Let's have aluminum. Take a look at aluminum. And then we have oxygen. And then we have hydrogen. Do you know what this indicates? This is a multiplier. You multiply it to the number of atoms. So for aluminum, it's made up only of 1 atom. So we have 1 mole. For oxygen, 3 times 1, 3 moles. And for hydrogen, 3 times 1, 3 moles also. Times, we multiply them to their corresponding atomic mass. So aluminum is 26.98, 26.98 grams per mole. So that is just 26.98 grams. We can sell the mole. For oxygen, times 16.00 grams per mole. Therefore, we have 48.00 grams. Again, we cancel out the mole. For hydrogen, round off to 2 decimal places, that's 1.01 grams per mole. Therefore, we have a moment, grams per mole, cancel the mole, 3.03 grams. We will add everything there. We have 26.98 plus 48, right? 0.00 plus 3.03. The molar mass of aluminum oxide, hydroxide, or your Kreml is, in 1 mole is 78.01 grams per mole. Okay? 9G, I hope you know how to get the molar mass of a substance. Okay? For any question, just see Miss Michelle. For part 2, we will study conversion of moles to molecules to particles or vice versa. Okay. That's it. I hope it will help you in your preparation for the summative test. Bye.